Construct an equilateral triangle inscribed in a circle. We have our circle, we have the center, and we have a compass. Let's start the same way as if we were making a regular hexagon. Let's identify a point along the circle, anywhere on the circle. Let's now mark the radius using the compass. So moving the compass until the point of the compass is located at the center. Now stretching this pencil point until it snaps in place there, that is our radius. Now that we know our radius, we're going to be swinging an arc from, and notice I haven't changed the compass setting, from the initial starting point, going through the circle right there by just pressing on the pencil point. And I want to identify the intersection point of that arc and the circle. Now again, moving the compass, spinning it a little bit, and swinging your next arc. And we continue this all the way across the circle, all the way around, until when we're done, we have 6 equally spaced points on the circle itself. So those are the normal steps for constructing a hexagon. We are constructing an equilateral triangle. So we'll see how these 6 points can be used to help us. All right, now here's my last arc. We want to just double check that when I swing this arc, it goes through my initial point. That will be our test to see if our construction was accurate, and it is. So we now have our 6 points, and we're going to start at any one of these points. And instead of going to the very next point, we're going to skip the next point, but go across here. There's our equilateral triangle. But I want to show you how to use this special tool, the custom tool. So I'm going to undo that and instead grab my custom tool, tapping on it. It comes onto my workspace with 5 vertices. If I click on a vertex, it goes away. Click on a vertex, it goes away. Now drag this point or any of these points to any of the points on the circle. So maybe I'll take the bottom point and I'll snap it in place right there. This next vertex I'm going to drag across, and I'm going to drag this one across. So that is my equilateral triangle. I can measure it 2 ways. I can use my utensil, use my protractor, and measure that this angle, that each angle is definitely 60 degrees, and you will see that it is. So that's one way. But back in Euclid's day, how they measured for equilateral triangles was they used the compass as the measuring tool. So this side of the triangle is open to that compass setting. And now I can swing the compass and see that the other side is congruent. I can reposition and swing and check that this last side is also congruent.